Amber, do you want to just tell me who you are? Or just volunteer to take some notes? These are all good options. You got them there? Yeah, I've got them here.
You got them there.
Yeah.
Can you just...
I'll do it. Yeah, I'm here. I don't know who volunteered. Hello?
I didn't see myself on the
No,
agenda.
wait. You're okay. You are on the agenda with Magnus, and we're just getting your slides.
You're on the agenda as a dash or not. So you're on the agenda for how it looks like a power outage. We have uploaded slides.
Yeah, pretty fine. We're getting there.
No, because I was looking at the agenda earlier, I still didn't see it, you know,
Right.
on what's on the site.
Right. Okay.
I just went to the site and I see that there's 3-4.
Okay, so what time is it? All I need to know is what time is it.
Do you want to start? You can do the maths.
We have a number of things capable of causing delays and congestion for you. Is the short answer.
Yeah, that's fine.
That's why we put you there.
And put your magnets so that you have to put access on that.
We're going to use all our agenda time, so they're probably more or less real.
Yeah.
You're done. Well, it's just a possibility. Yeah, we should be fine. I'm getting there. I'm kind of logging in. Okay, I now have a copy of this. What's it called? 3-4. Quick.
3-4 quick trains. 3.4 quick transport mechanisms.
Okay, we'll be done if it ever starts going again. I think some other people might have similar ideas. It's looking very slow.
I can make that work. So it might actually work. I'm sure all those pictures in the email that I already forgot.
Okay. What time are we starting at? Just about now.
Yeah,
I can't get this to work.
We're in fact already 5 minutes.
Do I have to do this yellow box thing before I can do anything? Because it just shows thing.
Yeah.
But we can always start the meeting. But we can't start the meeting. You know, we've got to start this show rolling, and we need a note taker and a Jabber scribe. Do we have offers of a note taker for the meeting? I think it'd be good if we could have somebody take some notes as well. Okay. Are you two, between you, going to take notes?
If the two of you take notes, that'd be great. That way one the other can take notes.
Yeah, we're doing that now. Okay, that's good. Right, okay, so we have the right things. This is Tsvwg. We are in Montreal. We are going to meet twice this session with a short gap between the two sessions. And I'm Gory Fairhurst.
And I'm David Black, and Wes is not here. Let's see. And let's see, our AD is on the remote as well. Spencer is out there. Okay. So hang on a minute. There we go. This is the note well. You've seen it before. It applies to you. We've got a note taker. Have we got a Jabber scribe? Anybody in Jabber at all? Okay, Randy will be, sorry, your name? Craig. Okay, my apologies. Craig will be Jabber scribe. Thank you very much. Please note that Tsvwg is the thing the chairs look for when new drafts are submitted to see whether they might apply to us. Okay, document review. Reminder: document quality relies on reviews. Please review documents in your working group, at least one other document in another working group. If you'd like documents that you care about reviewed, please review other documents. Scratch other people's back; they'll scratch yours. Okay. Accomplishments and status. We've had no RFCs published since the start of London IETF. However, we had 4 RFCs published between Singapore and London, demonstrating that in addition to network traffic, output of this working group is bursty. There are 2 net drafts in RFC editor queue. The DivServ WebRTC QoS draft has been there for a while. It's in misref state on a number of RTC drafts. There's a massive WebRTC draft hairball or tarball that will eventually pop out of there, and this is part of it. DSCP IANA process changes, that is at the RFC editor, and the RFC editor is editing. Hang on. That one. Okay. We had one more ID that almost made it. SCTP, errata, and issues. This one is still at the IESG. There'll be a technical update on this later in the meeting. The status update is the ISG has taken a look at it, and it's now in the hands of our area director, and he gets to choose wisely, as I think Spencer would say. We have 2 inner drafts, working group chairs and authors after working group last code. These are the 2 forward error correction drafts. There'll be a slide late in the deck that will show you what the inclusion of working group last call on these. Working group last call is concluded, and I think we need one more set of minor updates before these go to the IESG. DivServ lower effort per hop behavior draft. That'll be later in this session. The plan is to conclude working group last call later today with the discussion on the slides in that draft. We're likely to working group last call these 2 ECN tunnel related drafts in the very near future. I was hoping to working group last call them before this meeting. Other things happened while I was busy making plans to do that last month. So these will get last called in the very near future. There are 7 additional working group IDs listed here. Most of them are on our agenda. The one that really isn't is tunnel congestion feedback. That draft is on hold while a use case for it gets worked out. The use case is over in the service function chaining working group, and as that work moves forward, this draft will get picked up and move forward also. Related drafts. On the agenda here, path MTU detection via V6 packet truncation, which is a draft that was initially submitted to 6-man, but we want to talk about it here because path MTU is something we care a lot about. Transfer header encryption impacts. We've talked about this a few times. There will be requests for group adoption here in this meeting. TCP encapsulation considerations, which came out of a talk at TSV area, developed out of a talk at TSV area in London. L4S and DivServ, which is part of the L4S draft set, which will come up in that item, and IPv6 reservation protocol, which is a new draft we'll talk about down the end of the next session. All right, related drafts. 2 more drafts are transfer related but not on the agenda. One is the priority switching scheduler, which we've reviewed here and which we will support publication of via the independent submission editor track. I need to do a few more things to go dot the I's, cross the T's, and say this is a fine draft. TSVWG supports its publication. ECN NSH draft East Lake SFC NSH ECN support. This is the SFC draft that has the usage of tunnel congestion feedback. That'll be discussed over in the SFC working group. Then we have 3 internet drafts. Draft IETF into area tunnels, which Joe Touch has been working on over in into area. Fragmentation fragility, draft Bonica into area fragile that Ron has been working on. And a draft on SOX protocol version 6. Okay, so now we get to start telling you where you are on the agenda. In a little bit, I'm going to show you the agenda, and we will go ahead and see if we need to do any bashing. Do want to right now go through the milestone review. Okay, milestone review. Was originally hoping to get the 2 ECN encapsulation drafts done for this meeting cycle. That's going to be next meeting cycle, so we're going to move those 2 dates to October. The next 3 are in good shape. The working group last call is done on the 2 forward error correction drafts, and we're about to finish off working group last call on the lower effort PHB draft, and in addition, the related DSCP IANA allocation mechanism change draft is already at the RFC editor and being edited. So those 3 are in good shape. For reasons that we'll talk about more when L4S comes up, the September dates for L4S are, shall we say, a wee bit optimistic. We're going to move those out to July of next year. Is Bob Briscoe here? Yes, he's here. Bob, is that going to, is that a better approximation of reality?
We're aiming for September. We're ready.
You're aiming for September for working group last call.
Optimistic?
There hasn't been absence of discussion on the list about the documents.
Yes.
Okay. Right.
Yeah.
There's a reason for that, but I can tell you about that.
Yeah, I know. We've been
because all the discussions going on another list, but I can't tell you about that.
Yeah, right. Okay. In any case, we'll push the dates out to July, and there's positive credit for getting it done earlier. SCTP NAT support is Michael Tuxen back there somewhere. Is October still a reasonable date? I think it is. Yes. Okay. Good. Transfer options for UDP, packetization layer path MPU discovery for datagram transports. Those have end-of-year milestones that still look plausible. Tunnel congestion feedback is unlikely to be done by the end of this year, but we'll adjust that date when we get to Bangkok. And courtesy of the ISG. In part of the ISG review of SCTP errata draft, we picked up a milestone for a year from December for a BIS version of RFC 4960, a new rolled up SCTP spec. So that's the milestone reviews. Quick go through the agenda. You are currently at item 2 here, agenda bashing. We're going to do in this session the lower effort PHB, concluding last call, datagram path layer, packetization layer path layer MPU discovery, IPv6 packet truncation, a couple of discussions that have come our way out of the quick working group. Jana Iyengar wants to talk about quick transport mechanisms, and Magnus has some quick and ECN details to guide us through, and hopefully we won't get lost. Wait a minute. Interesting. There you go. Transport header encryption impacts. That's Gory, Fairhurst, and Colin. That we've talked about for a few sessions. We're going to talk about rigor adoption and then TCP encapsulation considerations. That gets us to the break. After the break, the SCTP drafts are the 2 drafts that we're looking at that are being dealt with here. The NAT support draft and the errata draft, plus some plans for the BIS RFC to 4960. UDP options. L4S draft, which now includes a 4th draft on diffserv, and finally a new draft proposing a new idea for an IPv6 reservation protocol. So that's the agenda. Any comments? Going once? Going twice? Consider it bashed. All right. So Vincent sent along this slide, Vincent Roca, for the two drafts. These are both about updating the forward error correction framework. We've had a bunch of good solid reviews during group last call. A number of things happened. The big one was that the pseudo-random number generator got replaced. And there's minor typos. So is Vincent here? So I'm guessing the story is that we're waiting a little bit for one more version of these, and then those go to and then those get submitted to the IESG.
Yeah, yes, probably. I have a few things to update, but very minor corrections.
Mm-hmm.
Otherwise, as you said, we made a lot of modifications to this document during this previous period. We clarified a lot this parameter derivation section, and we changed totally the PRNG for reasons I won't detail here. I mentioned this on the list, and I also did a presentation during the NWCRG meeting today morning. So if you're interested, do not hesitate. You can get in touch. I can explain you. Otherwise, there's already some material explaining why we did it.
Right.
And we have related work follow-up in some way. We are considering using RLC within the PWIC as an example of FEC scheme that could be useful. That's all.
Okay, excellent. I want to thank Vincent and thank the expert reviewers. We got a lot of good support on reviewing these drafts, which require detailed knowledge of the domain to check and review. So thank you.
You're welcome.
Okay. All right. Okay.
Roland.
Yeah, this is a brief update on the lower effort PHP draft. Next slide.
That might actually work. Give it a shot.
Yeah, it works. Okay, great. Okay, so working group last call started at end of May, and there weren't many comments, but there has been several reviews earlier on earlier versions, and so yeah, I incorporated only the few comments from Brian and David. I think Fred had one comment on updating the RFC 4594. David responded to that. That's probably the right thing to do. Fred wanted discussion. I don't know. You want to say something?
I guess my comment was that if we're going to rev that, there's probably quite a few things to go rev. And it would be good to have a list of what do you want fixed?
Yeah, and I think that's a follow-on effort to this. We need to make just enough of an update to tell people who look at 4594 as it currently exists that they need to start using the new DSCP in preference to CS1 for scavenger traffic.
Okay.
And that's what's needed. That's what's needed to move this one along. And then maybe if you've got the appetite for it, we could talk about a 4594 BIS.
Well, either one is a 4594 BIS. If you want, I can literally make that change. And it becomes 4594 BIS. I'll bet there's a note.
If you open that can of worms, there's more than one worm in there.
Right.
Hence my comment. Could we enumerate the worms?
I think that'd be a fine thing to do here, but I think for the LEPHB draft, we simply need to have that draft contain the text update that is to be applied to 4594, and it moves forward on that basis.
Okay.
Yep.
Yeah, we can do that.
I just tried to see what is RF3622 and it didn't make any sense, but RFC3662 might make sense.
Yeah, sorry.
That's the correct
typo.
That's the correct one. Thank you, Tim.
Sorry. Didn't remember my own RC number correctly. Okay. So yeah, the changes. there were some suggestions of also incorporating the scavenger service term into that draft in order to let people find it by Googling for that or so. So I added also some more history, just putting out the relation to that. And there were some requests from David, I guess, for more references. I added them. And I added text to the RTC Web or QoS draft, right? So what needs to be updated there? That probably needs review. I revised the text slightly on congestion control in case it gets remarked to best effort. And some small other fixes. So next steps, what I didn't address so far was Turles Eckert's comments with respect to multicast. So he just suggested to have a small, I don't know, paragraph or section about the problem that you want to probably avoid replications of lower effort packets to busy output ports, so that packets don't get replicated and then dropped directly afterwards. And Turles also suggested to include the keywords DSCP and scavenger in the document title. I also didn't do that. Maybe if there is support for that, I can do that. And we need basically to resolve the issue with the draft in the misref. Maybe just the suggestion for updating the later RC is okay. I don't know, because it's maybe too far in the process right now. And so I tried to submit version 06, incorporating any open issues that come up right now or in the next week.
I'll comment on the first set of bullets. I think in this case, the DSCP and scavenger thing is well worth bringing up because we're replacing something which is rather obscure in the RFC series. So we really need to be clear that people find it and there'll be good chance of people actually reading this rather than the previous thing. Okay. So that'll be good, right? Do you comment on this?
Brian Carpenter, just commenting directly on that. If it gets ugly to include it in the title, I don't know if it will or it won't. When you actually get to auth 48, you are asked to supply keywords for the RFC editor search, so you can put it in there.
But you can definitely put it in the abstract.
Yeah.
Okay, about multicast. I think it would be good to include something on multicast, but the text should be limited to, if you're doing multicast, this might also apply, and there might be things you need to consider to prevent going wrong. And I would just leave it there at the moment. We're not specifying multicast forwarding here, but we kind of are specifying diffserv. So, or we are specifying diffserv. So we should make sure there's heads up that there are multicast considerations here, and you shouldn't do the wrong thing. But saying what to do, I don't know that we can say what to do.
Maybe, I mean, Turles just offered help, so.
Excellent.
Yeah.
Okay, we'll need to check that text on the mailing list, and I'll take an action item to. So other people should do this also, but I will take a look at the revision to RTC Web Cross. I'll also take a look at the revision, the update text for 4594. I believe the path forward on RTC Web Cross is, let's go and write the before and after text that we want to see. And then after the IESG approves this draft, we can then figure out what to do. If not, an easy path and likely path of that forward is that RAD asks the RFC editor to go make that change, please.
Okay.
So to conclude, this draft has passed working group last call. If you have additional comments, you can always provide them on the mailing list because the IETF will move it to IETF last call. So still possible to comment, please read. But we've concluded the formal working group last call and we're trying to finalize this document. Okay. Please prepare a new rev.
Yep.
And Roland, we owe you beers or whatever your favorite adult beverage is for putting up with this. Thank you very much.
Tom next.
What happened?
That's interesting. No, we're gonna have to, okay, we've got to. Try that.
Okay, it works. Hello, I'm Tom Jones, presenting our draft. Datagram packetization layer at path MTU discovery, which, I don't know, some people see much of a mouthful, but I seem okay with it. So, changes since 0.1 that I presented in London. The 0.2 Rev addressed a lot of the comments we got from the working group and Magnus Westerlund in particular. And from that, we updated the requirements list for the algorithm. We tried to document a simpler black hole detection that was more self-contained in the algorithm itself. Application implementation discussion and some text on dealing with flapping paths where we have routing where we're getting two different MTUs and trying to detect that. And then the next rev, we came through and we updated all of the figures. We added more detection on black hole detection and a figure to try and capture just the simplified algorithm. We added a figure relating packet sizes just to try and explain what all of these different terms we're using are. We updated the big state machine we have. Yeah. Okay, so since 0.1, we've done some terminology changes. We thought the term effective path MTU was too much to say, and really the right conclusion from the DPLP MTUD algorithm is the PLP MTU. So the packetization layer's estimate of the path MTU. And this is the number we're consistently going to use. And we think we've got all of them. I think we're okay. And Gori went through and changed every instance of ICMP verification to ICMP validation. This is very difficult ground to tread. People like to swap different terms of those. We think this is correct.
Okay, Tom, one small request. This change looks good, but would you or Gori or somebody read this draft against the int area tunnels draft so we have a coherent set of MTU terminology across both of them? Yeah, I see a look at his face because we know who the author of the draft is.
You could have responded from over there.
Hi, Gori. Hi, I'm Gori First. I'm an author. The terminology is messed up, David. There are different flavors of this, and I think as an author, what I would propose is we choose a term very clearly, and we explain the reference to the other terms in the terminology bit, which is what we've now tried to do.
That would be fine and dandy. I just would like it to be that someone who reads this draft and the int area tunnels draft doesn't see the same term used to refer to two different things, and your proposal to explain what all the terms are that got used over in int area tunnels is an excellent idea.
We think we're doing that now, so
okay, good.
We will check.
Ron Bonica, Juniper Networks. Yeah, in the int area, we have the same problem that we have many drafts that talk about the same things. Maybe it'd be a good idea to abstract the terminology and put it in a separate short document. You know, I victim tier myself to do the work if it needs to be done.
I mean, if you use our terms, I'm perfectly happy. No,
Thank you, Ron.
Yeah, that's a fair point. And we'll have to talk about this, and we'll definitely speak to Ron.
Okay.
Sounds good. A picture. So these are all of the different terms we have when we are talking about packet and probe sizes in the network and our algorithm. And so there's really is quite a lot here, and it is very difficult to keep these terms straight. And so at the very bottom, well, the lowest down the diagram in the middle, we have our new term, the PLP MTU. And effective MTU inside here could really refer to several of these different numbers. And so the PLP MTU is the number our algorithm finds. It is not the number we can probe for because we have headers. And it's not the actual PMTU because we have logical step sizes which might make it different. And then below that, as a smaller value, we have the MPS, which is what we would signal from the PL up to the algorithm. And then going down, we have our base, and then we have a min MTU, which is probably hopefully close to the base. So since the last rev, there's been quite a lot of discussion in the quick working group. And
Igor and Magnus gave us review comments on this, both sort of coming from the same direction. Igor raised a lot of questions about how we handle packet too big messages and state transitions and what we do with different sizes. And Magnus asked us questions about PTB and robustness, and we think we have addressed these. We've spoken to both of these people, so hopefully we're all on the same page. And then Timur Volker has done an implementation based on a UDP application layer, and he's raised similar issues with terminology. He really doesn't like the past tense for probe to size. I don't know if this is a German thing. And so we're going to incorporate these. And he also raised some issues with the state machine. All three of these commenters raised issues with the state machine, and most people do. Okay, so reacting to the questions on PTB, this is not captured in Rev 03, but we're going to do this for the next Rev. And this is what we think we should do. And we'd quite like feedback if this is actually the right case. So if we get a PTB where we're in the done state, we should reduce down to a safe size and use the value in the PTB to start a search algorithm. And we think that's a nice step. If we get a PTB in the base state, then this is probably an error. If you're getting a PTB for a base size IPv6 datagram, then this is invalid in your network. And IPv4, there's numbers we can use, and the numbers we can use are very small. And we think this is actually just an error state. And we're going to write the text so this can be left up to implementers to deal with. So if they want to use like a 48-byte MTU, they can, but we don't want to. And then we have PTB handling when we're in search, and we have 3 different outcomes depending on what the MTU value in the PTB is. So if it's less than base, this is invalid and we can ignore it, apart from IPv4. If it's less than our current path estimate, then we have a signal from the network saying what our estimate of the MTU on the path is wrong. And so we can move to base to be safe and then start searching with this value. And if we get a value in between our search probe size and our estimate of the path, then we can use this as an input for our search algorithm. And so this is what we think. Hopefully people will come and argue with us if they think we're wrong, but I think we're quite happy with this now. No one's standing up. Okay, quick. So there's been quite a lot of discussion on this on the quick list. And we think quick is probably a protocol to capture that's quite relevant for the draft. And so I did work at the hackathon this past weekend, and I implemented a small subset of the algorithm without ICMP handling on top of MozQuick. And the conclusion from that was this is entirely possible, and all of the mechanisms are there in the protocol. And so we're happy with where quick is now in relation to our protocol to include text. And speaking to Magnus, we have sort of found that maybe load balancers will need more states so they can handle PTB. And as I understand, please correct me if I'm wrong, so there's 2 directions for connection IDs in quick. There's a source and a destination connection ID. And we think any quick probes that are going to go to load balancers will need to carry both IDs. Nobody looks angry, so it's okay. And so we need to figure out how that's actually going to work with quick. I haven't gone back and read the draft, but yeah, so that's our plan right now. Okay. The state machine we have right now is very big. It almost does not fit on 1 page of paper in an ASCII art diagram. And we think we need to redesign our algorithm around some core components. And so we've identified 4 pieces. The first 2 pieces of the algorithm are the growth phase, where we are trying to grow and discover the actual PLP-MTU of the path. We have a reduction phase, which is driven from two mechanisms. And this is when our estimate is incorrect. And so we have black hole detection, and we have ICMP path too big handling. And we think these are the core pieces that we can describe separately and then integrate together into the full algorithm. And we're going to update the document hopefully for September, and we will rev the spec around this. And then there are 2 more states. And so there's this error state that I alluded to where we're getting just really strange stuff from the network. And we think we know what to do about that, but it's probably going to be quite contentious text to write. I can see who I'll be arguing with. And then finally, we have this discussion about robustness, and resilience in search and when we deal with inconsistent network state. And so we really need some real world information to feed into this discussion so we can do detection of weird broken network paths and so that we can do the right thing. And we're going to work towards this for November. Okay, and that is me, and I will take questions.
Igor Lubashev. So first, thanks for working with us to improve this. Suggestion for error states. The way I would think about it, I mean, your error states are typically due to PTB that's claiming something that shouldn't be the case in the network. I would probably just equate it to ICMP that comes and says things like basically network is broken, like destination unreachable, and ask to treat the error state just like you receive what you would do in case of those packets.
Yeah, and so the error states are partially for things which are just weird. Getting ICMP for network MTU values which are just generally invalid for our address family, and then dealing with malicious attacks where people are able to inject valid ICMP messages, and we just have to deal with that.
Same thing. So valid looking, destination unreachable could be spoofed just the same, or they could be coming from who knows why.
One thing to consider in error states is misconfigured tunnels. IPv4 misconfigured tunnels that fall below the minimum required MTU are kind of unusual. V6 less so because the minimum MTU is somewhat larger. So that's something to think about as a possible cause of errors.
Yeah, Gary first as an author again. One of the error states which is actually meaningful is when your application says it's going to send 1,000 bytes, and that's the minimum. And then your error state says the only workable thing is 576. And you know that IPv4 actually supports that as a smaller number, and your application kind of wants to go there if it really has to, but it doesn't want to drop back unless it's explicitly told that the other one doesn't work. So there might be some error states that actually are useful to work with the really broken stuff like that.
Right, and I think that's also a good way to think about the possibility of dealing with misconfigured V6 tunnels.
I think that'll be fun. I don't understand what I need to do there, but that's always good. But let anybody want to talk to us, then please come and talk to us. The other thing we should announce, though, is there are several implementations being played around here. There's the Timo one. You have some code, Tom?
Oh yeah, I have. I'm going to say 3 implementations.
All right.
The division's a bit fuzzy.
And there's some stuff in Quick being played with.
Well, that's me.
That's you. One of them is you. Oh, that's one of the 3. Okay, but it's just nice to know that there's some code there. So if you want to kind of play with the code or get examples, then tell us as well.
Michael Tuxen, yeah. The implementation of Timo is just using UDP packets with something in the payload to detect the probe packets back, and we also have an implementation for SCDP.
Sorry, Michael, could you... So we're planning to keep the 2 real implementations we have, so Quick and UDP options going. Will the SCTP one follow the draft?
Yes.
Okay. So that's
eventually
3 implementations.
That's very good at this stage.
Thank you.
Thank you all very much. All right. Okay. What are we up to next? Okay. So Ron is going to do this one. Welcome.
Thank you. Ron Bonica, Juniper Networks. I'd like to talk about this draft that's going on in the 6-man working group, and also about a recommendation that we got from the TSV working group about how to change it. Maybe talk about that change a little bit more, and if we all agree on it, I'll make the change in the next rev of the draft.
Is it clear there, or I can dance for you? Your choice.
Okay. IPv6 allows for fragmentation at the source only. So source nodes have a choice. They can either refrain from sending packets greater than 1280 bytes, which incidentally is what most of them do these days, or they can maintain a running estimate of the PMTU and refrain from sending packets that are larger than that estimate. And they've got two tools to do that. One is PMTUD, the other PLPMTUD, now called DPLM.
Come on, if you can't get that right, then.
You can say that. We can say it's so tight.
Yeah. Anyhow, this tool certainly helps with some of the PMTUD problems, and maybe tweaked a little bit to help with DPLPMTUD. I can do that in Morse code too. Okay, a second to talk about how PMTUD works. The source produces an initial estimate of the PMTU, and that initial estimate is normally the MTU of the first hop along the path. That estimate may be larger than the actual PMTU. Then the source starts sending packets. The packets are never larger than the PMTU estimate, but they may be larger than the actual PMTU. When a packet's larger than the actual PMTU, the intermediate node that can't forward the packet drops it and sends an ICMP PTB to the source. And if that message reaches the source, it updates its PMTU estimate and everything is fine. That's if the ICMP PTB reaches the source. Now that we've talked about how PMTUD works, let's talk about how it breaks. Well, sometimes that ICMP PTB can't make it back to the source. And there are a bunch of reasons why. The most common is a poorly implemented firewall rule. Lots of consumer CPE will not allow the ICMP message in because it's coming from an unknown source, a source that's in the middle of the network. There are other reasons too, but we don't need to get into that for the purpose of this presentation. In any event, when this happens, the ICMP PTB message does not make it to the source. The source does not update its PMTU estimate, and a persistent black hole occurs. So this is how PMTUD breaks. So we need some new procedures, and let's talk about what those new procedures are. An upper layer protocol is emitting a packet, and it marks that packet as being truncation eligible. And it's the upper layer protocol's decision whether it marks the packet or not. When an intermediate node can't forward a truncation eligible packet because of an MTU issue, it truncates the packet, it marks it as being truncated, and it forwards it to the destination. The destination node sends an ICMP message back to the source. And the assumption here is that the ICMP message from the destination node is more likely to make it to the source than an ICMP message that originated somewhere in the middle of a network. It's more likely to get around that misconfigured firewall. It's more likely to not have the anycast problem that we referred to in the last slide. So let's talk a little bit about mechanics. How do we do this? Well, to mark a packet as being truncation eligible, we have a new destination option called the truncation eligible option. And to mark a packet as having been truncated and still be eligible for further truncation by another downstream node, we have this truncated packet option. So one indicates that a packet's eligible for truncation, the other indicates that it's been truncated and it's eligible for further truncation. Let's talk about what the truncation eligible packet looks like. It has, right now, it has two fields in it, and there's a proposal from this working group to add a field. There's an option type that's TBD by IANA. It indicates that it is truncation eligible. The first two bits of that packet indicate what a destination node should do if it receives the option and it does not understand it. And in this case, it should just skip over the option. The packet was truncation eligible. It was not truncated. It's all irrelevant. Just skip over it. The third bit of the option type indicates whether the option data can be changed en route. Since there's no option data, it doesn't matter. And the second packet tells you the length of the option data. There's no option data, so it must be 0. Whoops. Next is the truncated option packet. This indicates that a packet has been truncated. So when a node has to truncate a packet, it overwrites the truncation eligible with the truncated packet. This one has a different action if it's received by a node that does not recognize it. Its action is to discard the packet and send an ICMP parameter problem message. And again, the change bits are irrelevant because there's no option data. So, summarizing quickly, source node procedures, it emits a packet with a truncation eligible option. Destination node procedure, the intermediate node attempts to forward a packet and encounters an MTU issue. If the packet's eligible for truncation, you truncate it and mark it for truncation and forward it. If the packet isn't eligible for truncation, you do what you do today, drop the packet and send an ICMP. That's for backwards compatibility. At the destination node, if you receive a packet that's truncation eligible and it hasn't been truncated, just deliver it to the upper layer protocol. There's no special action to take. But if it receives a packet that has been truncated and it recognizes the option, send an ICMP to the source node, and the ICMP MTU reflects the length of the packet. By default, you discard the packet. However, the upper layer protocol can register for delivery of the truncated packet. Now, one thing that it can do is take the packet, it realizes that the stream's been corrupted because that truncated packet option's there, and it might just use the metadata. It might use the metadata to say, oh, I now know the PMTU between the source and myself. Maybe I'll use that to signal at layer 4 what the MSS is. So it might be, the metadata might be useful. And by the way, if the destination receives a truncated packet and it doesn't recognize the option, it's obliged to drop the packet and send an ICMP parameter problem. So you won't try to keep truncating packets. Now, what are the benefits of truncation? It allows you to use larger MTUs. At very least, it fixes the PMTU-D problem. It might also provide some tools that upper layer protocols can use to learn the PMTU without relying on ICMP at all. We can skip over these slides because it appears that everybody's got the idea. But I'd like to bring up another idea that came off this list. Somebody recommended that we add yet a third option. This option could be used very early in a TCP session or a transport layer session. The option says, this packet is transport eligible. It has some additional option data. It tells...
Truncation eligible, you meant, Ron.
Oh, what did I say?
Transport eligible.
Oh, sorry.
Most packets are.
I'm still tongue-tied from trying to say DLPM to you. In any event, you have this new option. You pad a packet, the very first packet in a session, with lots and lots of zeros. The new option says this packet is truncation eligible, and the option data tells you how many bytes of that packet are not padding. Now, it is very likely to be truncated. It's truncated downfield, so the option type is overwritten with the truncated packet option. Now you get to the destination. The destination looks at it and says, oh, this was a padded packet and it was truncated. You can tell whether all of the useful data made it or not. If all the useful data made it, you've learned the PMTU and you have all the useful data. If all the useful data didn't make it, well, you've at least learned the PMTU and you throw away the data you have as if the packet had been picked up. So anyhow, my questions for the working group. First, is the work interesting without that extra padding tweak that has been recommended? And second, is the padding tweak interesting?
I just want to rewind. I think you said this is very likely to be truncated.
Yes.
And I was with you until you said the word truncated because I was expecting the word dropped.
Ah. The packet is eligible for truncation. Let's say it's the first TCP's packet in a session, and it's carrying only a couple useful bytes. You pad it out to 65K. So it is very likely to get truncated at the first hop down to the MTU of the first hop, as opposed to fragmented at the first hop.
But I think it's more likely to get dropped because there's going to be some legacy node between you and the first router that understands how to do the truncation.
Good point. It is likely to be dropped because of the legacy node that doesn't understand any of these
Right.
options.
So does that, I mean, you knew that already, right?
Actually, I didn't think of that, but you've got a
then
point.
I'm glad I got up here.
I would amplify Tim's comment to suggest some thinking about incremental deployment.
Igor Lubov, I think, well, if the packet actually, truncated packet does get to the destination, now it's a big if, I think it's interesting because for TCP, the upper layer actually can use way more than just metadata because effectively you got maybe big N minus a small delta of the actual data that doesn't need to be retransmitted. It can be ACT. So that is useful. The question is, there is a premise that ICMP from the destination is more likely to reach the source. And for any cast, it seems plausible. But for other reasons, I think it basically needs to be tested. Did you do any sort of tests for measurements to see if the same kind of ICMP sent by the source is more likely to reach?
Yes, we know of a common bug that's in consumer CPE. What they will do is allow a packet to come in only if you've sent a packet to the same address out recently. Well, if you've sent a packet and the ICMP comes from the destination, it will get past that firewall. If it came from an intermediate node, it won't. Now, granted, this is a bug in the CPE. The CPE shouldn't, when it gets an ICMP message, should look at the quoted packet in the payload to determine if it should let it in or not. But the bug is so common that...
So do you have any quantitative estimate for how much more likely you're to get?
That I don't have. I just know that the bug is very common. I don't know if I tested it, how many nodes would have it.
Tom Jones. Tom Jones. So three things we're on. It's very easy. It's D, PLP, MTU, D.
Okay.
Gesundheit.
So for the extra bits, I think this is a requirement to make this feature useful. But if there's enough information to reconstruct the original IP datagram, then I'm hesitant to say this might be a solution to PLP-M2D for TCP.
Okay, so you're talking about adding the extra bits that tell you about but the base draft, you're okay with?
I think adding those bits is required.
Adding the bits is required. Yeah. Okay.
Okay, and then a question.
So just a second. The reason being that the TCP header doesn't have a length field that's different to the IP length. So,
okay.
So we should be careful about lengths we pass up to TCP in any way.
Yeah.
So unless I hear otherwise, I'll respin the draft, adding that extra option data.
Please do. Okay, and then a final question. So this is quite a new draft. There've been 5 revs since May. Do you think it's going to settle down and be ready for people to try and implement soon?
I'm hoping it'll settle down well before the next IETF. It revved a lot, mostly because I had way too much caffeine and a little attention deficit disorder.
I'm going to close the mic lines after Bob.
Mia Kulevin, I just got an idea from the Bad Idea Fairy. Why don't you put the padding directly in an option? I'm pretty sure there might be middle boxes already that help you stripping that.
I'm sorry, why don't I put...
The padding that you want to add to the packets for the probing, just in an option.
Oh, there's an idea. Oh, there is a reason why. The maximum size of a padding option is 255 bytes, and the maximum size of destination option header, I think, is only another 255. So we couldn't pad it out to 6K.
So,
Okay.
Michael Turkson, for TCP, the padding would be part of the TCP payload.
Yes,
So if it's dropped, the checksum is wrong.
absolutely. It would make the,
So
well,
if I'm willing to accept this data, I have to accept data with the wrong checksum.
I guess the checksum would be correct if the padding were stripped away.
What? So you have
I
payload?
suspect the checksum covers the TCP segment, and then this is added at the network layer as you generate this option and do it. So you need a length to be able to undo this. Is what I was saying.
Yes, the lengths come from the IP header.
Well,
TCP.
you need two lengths. Yeah. Tripod.
So the suggestion is there's two lengths. There's the length of the total IP datagram, and there is a length carried, which is the original size of the datagram before any padding is added. And so when you get these, you can strip away until you have the original IP datagram again.
But you do raise a good question that I need an answer to, the checksum.
Yes.
Should the checksum be correct for the packet before the padding was added or the packet after the padding was added?
Before.
Before. Okay, I agree with that.
Yeah, let's see. Let's easy out of this one.
So in the case of SCDP, we have padding chunks, and we can add that, and we can reconstruct the packet structure if we would ignore the checksum. And if I would do this I would only do this for probe packets where I know, I don't want to transfer data with it, so I just need to verify this belongs to an association and which number I use. So I could live for that case with the wrong checksum.
Okay.
So I've got a couple of reactions. You've mentioned a destination Fred Baker, in case anybody didn't know me. You've mentioned a destination option. So you want the router to disobey RFC 8200 and look at an option after the hop-by-hop option.
But only on an exception basis. Only when the packet cannot be forwarded because you've hit an MTU issue. Now, there is precedent for doing that. The precedent is cited in the draft, and it happens, there's an option called the encapsulation max, and I forget the RFC that does it, but there is one other RFC in which on an exception basis, you go all the way to the end of the destination options.
Okay.
But just V6 ups.
In fact, it only does this if you think about how an ASIC base
It has to parse past the hop-by-hop header to know whether.
Well, if you think about how an ASIC-based router is generally architected, you've realized you have a forwarding problem.
Mm-hmm.
You're kicking the packet up to the slow path anyway to send an ICMP message. So instead of sending the ICMP message, you're forwarding out the truncated packet.
Okay. Second comment. You referred to NAT-based firewalls as blocking, doing its own based defense. I don't know of very many actual NATs in the world. Most of them are NAPed. And so you find yourself looking into a UDP or a TCP header looking for a...
I never said anything about NAT-based.
You said that broken CPE equipment looks for address pairs.
Yes, yes.
Address pairs are NAT.
Well, there may not be any translation going on.
Oh, okay. Third comment. You said something about the protocol sending back a message saying, I've changed the maximum segment size. So I went and looked in RFC 793. Maximum segment size is, by specification, only used on the SYN packet, on the first packet in the session.
Mm-hmm.
So if it comes in a later thing, what does that mean?
Well, actually, this draft stays away from telling the upper layer how it should communicate back to its upper layer peer to use smaller packets. It says it doesn't specify any of that. This is just a tool that
I think you're
and
gonna
somebody
need-
else can use.
I think you're going to need to address that somehow.
Yeah.
Stay there. Al Morton. My coat is from Alaska, so winter is coming. Ron, I was shocked to see the word overwrite. You start out with truncation eligible, which is destination option, and somewhere along the line, when something bad happens, you get truncation happened. What happened to the are not modified? Extension headers are not modified, or removed, or added, or deleted.
Obviously, this is the stretch.
So I've got post IESG review stress disorder, and there's no support meeting this time. So what's going on? Why are you guys so special?
Well, granted, it is a big deal to modify an option identifier in flight. It's also a big deal to truncate a packet. Yeah. Well, dropping it is kind of, we have a lot of precedent for that.
Yeah, a lot of people drop packets.
We have precedent for looking beyond, for on an exception basis, looking at the destination at someplace other than the destination option, someplace other than the destination. Precedent for overriding an option type. Well, yeah, we do it, but only on this crazy exception basis when you've already gotten off the forwarding path. And it's a case where you would have dropped the packet anyway.
All right, so be sure you spray paint that on the ceiling someplace.
Yeah, yeah.
We're cutting a line, and we also need to make sure that we don't beat up too much on this proposal, since it seems to be the product more of coffee and thinking than necessarily good text. So, Bob, give us the last question.
Yeah, it was just on this incremental deployment thing. It's got to have some way of people wanting to do this without the packet being likely to be lost. And so, something like Happy Eyeballs would help. But I was just looked up RFC 7872, which is statistics on drop of the destination option, and it's between 12 and 17%.
Yeah,
so
and
even if this router supported it, or the first, all the routers up to where you wanted to deal with it supported it, you've then also got the problem that
Bob, is that drop the destination option or drop the packet with the destination?
Yeah.
Yeah, my worry would be even if somebody invented a way of drop the destination option and somehow carried on forwarding the packet, which then ends up with a really strange thing.
We
I think
actually,
there's many things here.
We actually talk about that in the draft. The very first thing you have to do is see if you're on one of those 10% of the paths. Yeah. And that's why there's another draft called Draft Bonica Unrecognized Destination Option, where you have a special destination option that if it makes it through, will send you an ICMP message, and if it doesn't make it through, will send you silence.
Thanks, Ron.
Okay.
I think my chair's summary of what we talked about here was that was much fun. Can you go and do some more thinking, and when you've figured out the IP layer stuff a bit more, come back and talk to us, because I'm really not sure how the transport interacts with this, but it looks like an interesting signal.
Okay.
So you'd be welcome here.
We'll keep you posted on the mailing list.
All right. Let's see. What can we do here?
So it's John.
Jana, we think your slides are uploaded.
Yeah, hang on. I need to insist to.
No, I think your slides are uploaded. David's finding out.
Hit that.
While they're trying to get the slides
Okay.
on, let's practice saying DP-LPMTUD and TCP-LPMTUD.
Oh, excellent. That's my next.
TCP-LPMTUD. I managed to do it. First time, and I managed to do it. I have not had too much coffee. My name is Jana Iyengar, and I'm here to very briefly talk about quick loss detection and congestion control. I will not be going into the weeds. I will only be touching upon a few things. It's a few slides and only a few minutes. So that's the name of the draft. Next slide. Oh, I could use this. I can use this, right? Wonderful. So very briefly, the premise of the draft is this. Quick's transport or general transport machinery is different from TCP's in some in subtle ways and some in glaring ways. But for instance, and this is not an exhaustive list, but it's the list that I could come up with. Send order in Quick is separable from delivery order in Quick. This is not so in TCP. The same sequence number is used for both send order and for delivery order, and that causes all kinds of hurt and pain. In Quick, delivery order is with streams and stream sequence numbers, whereas send order uses a packet number, and we explicitly chose to call it packet number instead of sequence number to avoid conflating the concepts of sequence number in TCP with that of packet number in Quick. Quick has monotonically increasing packet numbers. What this means specifically is that if there is data that is retransmitted, the packet number on the packet is not the same as what it was earlier. It's a new packet number that is still increasing. This is a pretty significant and a pretty big difference from TCP again in terms of how we think about the mechanisms. There is no retransmission in Quick. There is no packet level retransmission in Quick. Stream data can be rebundled and sent again in a new packet, but the new packet just gets a new packet number, and that goes along just fine that way. Acknowledgements use this monotonically increasing packet number, of course. And the receiver explicitly states ACK delay. Instead of inferring how long the receiver was sitting on an ACK before sending it, that's explicitly stated in the ACK. And again, there's sort of a fiddly bit, which is that we do not use a cumulative ACK. We use the largest acknowledged, which is sort of, if you think of it, it's sort of the right edge of what you would receive if you're receiving SACs, right? And not the left edge of what you believe has been received at the receiver. And ECN signaling is quite different, and you'll hear more about that in the next presentation that Magnus is doing. So loss detection and congestion control use all of these signals, and these signals are quite different in Quick than from TCP. So how does loss detection and congestion control, how do they look? Well, they're same, but different. So that's basically what it is. We have fast retransmit, we have early retransmit, we have timeout that look the same, but they're just slightly different here and there, and in some places significantly. And it's confusing when you see it, because then you go, huh? I thought this worked this way, but it doesn't. In addition to those differences in just the mechanisms themselves, because again, like I said, we have these signals that are different. We've introduced some other elements like an early retransmit timer, which is there in Linux, but not there in the standard, not there any RFC or any draft. We use tail loss probe, which is an expired draft. Somebody should really pick it up and run with it for TCP. But we have those things baked into the loss recovery draft in Quick, and those are a part of it. Again, because of the difference in signaling, we have a completely different spurious timeout detection technique than FRTO. It covers spurious timeout detection, but it's sort of hidden. And those are all things that are in the mechanisms. Congestion control, we specified in the draft, we specified Neurino in the draft for Quick, but we use again largest acknowledged instead of the cumulative ACK for a recovery period. This in practice turns out to be quite an important difference, because TCP ends up staying in recovery for much longer than Quick does. So again, these are I'm just touching on things. It's not to get into the details here. We are doing a bunch of editorial work. We will be adding a lot more rationale and clarifying the mechanisms in the draft over the next few months. And I am hoping to present it in much more detail here, or TCPM, or TSP area, maybe, probably Bangkok. But I want to give a heads up to this community. If you are interested, go read the draft and provide feedback. I'm happy to discuss. We will, like I said, we are doing a bunch of work on it.
So Gary, first, I have to accept the blame for inviting you here. We can have comments at the mic, but we are not going to discuss the Quick protocol functions here, because that's the Quick working group. So if you've got protocol stuff on all this discussion, join the Quick mailing list, tell someone in Quick, deal with it on Quick. But it's good to talk about it here. So thanks, Jana, for doing that. Randall, would you like to say
Randall
something?
Stewart, one little comment per Jana. If you look at the rack draft, it has
Oh,
tail
that's
probe
right.
in it. It's been merged
Yes.
together. So
Yep.
TLS probe has not died.
Yep. No, I know. I'm aware of that. I forgot that though. Thank you.
Michael Jackson, just a similar comment. Why not use rack? I mean, a version of rack for Quick instead of all the other mechanisms?
We could, I mean, in theory, so effectively quick loss recovery covers rack. Again, as the mechanisms are different because the protocol itself is different, but it effectively is rack. So rack uses time-based things, right? So when you're doing retransmissions, for example, it helps quite a bit because now you're looking at time from transmission rather than the actual packet number. As it turns out, because packet numbers are monotonically increasing in Quick, that actually gives you time ordering directly. So we don't need to look at time ordering outside of sequence numbers because the packet number itself gives you time ordering. In addition, if you want to look at the time from packet sent to do the reordering thing that rack does, we have that also. So yes, it covers rack effectively. It's not a rack for Quick, but it's covered in Quick.
Okay, thanks.
Just simple clarification question. I think when this recovery draft has initiated, I think initial design philosophy is something like using Reno.
Yeah.
But now it seems it's deviating. It's trying to, how can I say, design new congestion control based on new Reno, but it's better than new Reno. Is that the current design principle?
I would say that, no, so I would say it's still new Reno. There's one thing that is different that you may be alluding to that we talked about yesterday. Is that what you're talking about? So this is one thing I should.
Yeah, and also you are using timer-based loss recovery mechanism that is not inside Reno, for example.
Right. So the loss detection mechanisms can be slightly different than what's in the standards, and that's where rack comes in. So this is more TCP plus rack plus PLP, which is also in rack, plus early retransmit timers, which is not in any other document. That's the loss detection part. On the congestion control side, we've basically stuck with simple plain new Reno, but just modified it for the protocol things.
Parameter has tuned, but maybe we can talk offline.
We can. So one thing I will note is that Quick again allows for a receiver to send acknowledgements less frequently than every 2 packets, and we absolutely intend to exercise that freedom. Right now we are trying to figure out how to do this right so that the congestion control doesn't suffer. We've done some experiments with this, but we need to have a good signaling mechanism from the receiver to the sender to say, or the sender to the receiver to say how frequently the sender needs the receiver to signal, send ACKs back. But those are all things, again, that I'm happy to discuss in much more detail offline.
Another meeting, TSBTC. I don't know which working group.
Or maybe I can help with the question here. I've got a question to the people here. Many of the people here will be familiar with transport protocols and their interaction with the internet. If what you heard from Jana sounded good and you would think it would be valuable to find out more of an introduction about this so that you could actually comment on the Quick mechanisms, could you just raise your hand if you think that introduction would be something useful for us to try and arrange? Okay.
We could do this in a dinner. It's like 5 people.
I guess we saw half a dozen hands from those people in the room. We'll talk to the Quick chairs and figure out how to do this.
Thank you.
Thank you. Witness. So now we understood the quick overview of Quick. Let's delve into some real details.
Yes. So I'm Magnus Westlund. I will talk about the addition to Quick of ECN in the latest version, and the specifications is in those, since in these 2 drafts, the transport and recovery draft. Yes. So let's see. Yep. Okay, so let's start summary of what's actually went into Quick now with ECN. So it's packets with any type of ECN marking is acknowledged in a special ACK ECN frame. And it has counters for marking for the different marking types. If you get an ECNC mark, you send an immediate ACK with increased counter. So that's how the sender knows that you get a congestion mark in congestion indication. It's per direction verification of ECT capability of the path and the receiving host stack. So it's both being able, you verify both that you can send ECT marks, receive ECN related markings on the receiver side, and report them back. So that you're checking all of this functionality, both at start of connection and any connection migration that happens. If the receiver only sees not ECT, it will ACK back in regular ACK frame. And that's how you separate the two types. To cope with any kind of path changes, anything else that will screw up the ECT capability, you actually do a continuous verification of the values. You see that the number of received and ACKed packets is corresponded by a similar raise in the counters. And if it's something happening, then you stop sending. So to not get false benefit of ECT marks when you're not responding to the markings. When it comes to ECN black hole mitigation, there's some description of what you could do. For example, if you get the retransmission timeout during connection establishment, you could retransmit without ECT marks as a way of ensuring that you don't go into permanent connection failure. But there is quite a lot of implementation freedom around this black hole mitigation, how you would do it. You could mark 7% for package or anything else, but it's up to you as an implementer in this case. So let's see, next slide. Yes, I should add that I'm speaking on this topic based on my experiences writing up the PRs and trying to get the things into the draft, but there's also a design team behind the whole that's discussed a lot about how ECN in Quick should look like, etc. And they just took that and run with. So there's a lot of help from them. Also, quite a lot of changes from the editors of the document. So it's all a community effort, but I'm up here speaking for this. There's still some related issues in the Quick working group in their GitHub tracker. There's one about potentially optimizing the ACK formats. That's might happen or not, but it's at least ongoing discussions around that. The continuous verification and ACK loss handling that's actually been addressed in one way currently, so that issue has actually been closed, but it's something that resulted in tax changes coming out in the next version. It's merged in master currently. There's also an issue around detecting lying receivers. So, based on these issues and I had some kind of high-level questions or issues that came up around this, which we'll go into. I know we don't have time to go through all of them, but we'll see how far we get, depending on how much feedback I get. So, next slide. So, one thing that came up was that there's this potential attack, which is for if B is having a session with C, and you have an attacker A, which is on the side, but he gets copies of some or all of the packets that goes between B and C. He could actually remark the packet and re-inject them with the source address spoofing, so they reach C, and in that way drive down the congestion window for the connection between B and C. And so therefore, based on that potential attack, and with the fact that Quick has, as Jan said before, always increasing packet numbers, if you get the application, it's a true networked application, it's not a retransmission. We kind of said, okay, one way of dealing with this is saying that at least if you're going to do this attack, you need to raise your packets with the original connection, which makes it much, much harder to actually successfully do because of the extra direction. So therefore, we only report the first packet of any duplicated packets that arrives at the receiver. So there's some risk of missing a legit marking that happened downstream, so to say, of where the packets get duplicated. But and that could result in a slightly delayed congestion response. But I think this is a trade-off where seems straightforward for now at the moment to be, but people have opinions of this. You're welcome to comment on this, etc. Okay, next slide. So another thing which this has to do about this, maybe looking at other ways of doing the acknowledgement format is, will we actually see ECT zeros and ECT ones mixed in one packet flow now that we don't have any kind of ECN nonce style use, etc. And so and this actually has to do with, can we assume one? We could actually assume that we will see mostly markings keeping with what's the default here. And I mean, current recommendations following the classic ECN approach would be to set the ECT 0 period and only use that. If you do L4S with the corresponding congestion controller in Quick, you would only see ECT 1. That's my understanding of the whole thing. And you wouldn't see alternating, but and if you actually would see alternating, you probably need to have some dual controller states, etc., to deal with the different treatments from the network, which is likely to arise from having two different code points. So, David
Black on the floor as author of RFC 8311. I think you're on solid ground in assuming only one of the ECT code points in a single flow.
Yeah. David, does that mean that if you see another one after you that is unexpected, you should flag it up and do something?
I think I want to see where we go with L4S and its use of ECT1 before I speculate about hypotheticals beyond there. I got Bob right behind me. We're going to expand on that remark.
All right, Bob Briscoe. The approach we took in Accurate ECN was that the receiver is just a dumb reflector.
Yeah.
It doesn't make judgments as to what might come in the future.
No.
Because, what Dave was talking about is current experimentation, but the future is a very long time. And however, there is also the question of how quickly quick deployment is compared to TCP. Because in TCP, we assume that things take a very long time to change, and so you want a dumb reflector at the receiver so that senders can unilaterally upgrade and just expect things to be reflected back. But maybe a different question with Quick.
So I mean, even Quick has mostly the same kind of dumb reporting back what it sees. This was mostly from a perspective of, if you make an assumption that you expect to see one of those, you could actually optimize the reporting format to see that, and then you have only some exception indicators that, I see something I wasn't expecting.
Good. If this is only about optimizing reporting format, just don't.
So
yeah, I mean, we didn't in Accurate ECN. You could in such a way that you can report one or the other usually and not have to report them both or something like that. But
But my question was, if you're expected to see ECT 0 and you see ECT 0, and then you see ECT 1, do we have to signal that back to the sender? Is that a condition we have to do, or should we just ignore it?
I would have thought you do, because something's obviously going strange.
Yeah, that's what I thought.
Jana, there's a slight difference though. The optimization is not, it's not just an optimization, it's also about being able to reflect something accurately. So in Quick, the ACK format itself is actually quite extensive. It's expansive in the sense that you can have a large number of packets that are acknowledged and large number of gaps that are acknowledged, and there's a particular format that is currently being used. So part of the question is, how do you encode this information into the current ACK format so that we get the most accurate reflection back? And if we can make this assumption of there's going to be only one of the two that's default, it allows us to get a more sort of accurate description in the ACK back. That said, if we need to change the ACK format, I would say, so Quick has versioning, which TCP doesn't have. So it allows us to say that, okay, subsequent version of Quick will have a different ACK format and so on. If that's something we want to do, we could certainly do that.
We don't have to backshed the design of this. This can be done in Quick or the design team. It's just kind of knowing what are the requirements.
Yeah.
Yeah, I think what David said is useful to that.
Hi, Colin Perkins. I think we have a history of devices in the network which think they understand the TOS byte. And I don't have any statistics, but I wouldn't be surprised if we see ECT0 and ECT1 transmuting into each other. So something which can report that happens might be useful.
Yeah, I definitely agree with that, and I think we need to have that type of mechanism reporting. It's a question of how often or how it's done. I mean, the current format's clearly capable of reporting that on at least how many you've seen between each check, so that's not a problem. So,
right, Magnus, you decide how many questions you want to take because you've only got a certain amount of time.
Yeah, I think we can go on to the next slide if so. Yes, and then this was going to be the last one. So, detecting cheating receivers. So, I mean, this is the whole point that a receiver here could ignore to report a CE mark for the benefit of saying, we'll grab a little bit more bandwidth than on the other flows that are following and reporting correctly if they're sharing bottleneck with multiple flows. But that's the kind of assumption there. One way of detecting this would be able to mark CE marks, inject CE marks from the sender side, so that the sender knows that, okay, I sent this, I should get report, and if you don't get report, you turn off these end sending at all, because you have a lying receiver. The question around that was basically, there probably should be some limitations there. I mean, okay, if you send this very infrequently, it's definitely fine, but it shouldn't be sent too frequently because it might hide true CE marks. But I guess some thumb rule of if you send it every number of 100 packets, you're probably not really hiding that much. So, but if anyone has any more say about this, go ahead.
I think this is Bob Briscoe again. The draft that 8311 refers to about that technique. I was an author on that, and obviously you don't want to do it in a predictable way, so we don't have to write in an RFC how you do it, because the whole point is
well, it's if you says you random and know more often than every 100 packets, it still tells you something that you're not overloading it.
But you
but
certainly want to do it quite early in the session so that you know who you're dealing with. You don't necessarily need to go all the way through it.
Yeah.
Then you'll get game. But I hadn't actually noticed this. Is this a requirement or is it an idea?
This relates to one of those issues which was somebody brought up that they thought that should have better detection of this type of behavior, but
it's not in the draft.
No, it's not in the draft currently. No. Okay. So, Mia,
wearing which hat?
Mia Kulevin, just my personal opinion, I told this to you already. I think like any kind of those recommendations are not quick specific. So they shouldn't go in the quick document. There should be a separate document that applies actually to all kind of transport that want to use quick ECN.
So that comment at the mic from Mira was the reason why Magnus is here, because I looked at that and I said, if we're going to do this for quick, we should talk about this for the whole community, because it's a way of using ECN. So it should come here to have a little bit of a discussion at least for everything for this.
But I think it's really a separate
It is.
thing. It's independent of quick.
Yeah, the mechanism is independent of quick, the rules for doing it, etc.
And actually, you can do the same thing with injecting losses to see whether they're reported.
You could. There you go, Bob. I'm reordering them. Just a minute. We're short on time.
Yeah,
David,
final.
I was going to suggest, let's see, RFC 3540 was a first attempt at this done via different code points, and it didn't make it in 2020 hindsight did not make it into orbit. So I would advise a light, careful touch here. The idea that I heard about maybe run the Sandy check once early in the session sounded promising.
Okay, last comment.
Yeah, once again. Actually, I'm I'm not sure this is actually too useful, because if the CE markings get removed, then you compete with the rest of the world and see losses at some point or whatever. I don't know. I mean, like, you can get it.
It's all about depending on how much competition you have in the bottleneck. So.
Okay. You can discuss this one on this list.
Yes. Yeah, I mean, there's a mail on the mailing list for the other two issues also, so it's and there's the slides you can read. So we'll end here, and because we're out of time, and please comment on the mailing list.
Thank you.
May I ask the question I've been waiting to ask for the end? Is that right? Yep.
All right.
Yep.
And in the meantime, Tom, yeah, that's good.
Okay. It's more a suggestion from the experience we've had with Accurate ECN. The point you made about immediately sending an acknowledgement when you get a CE. It's been suggested, we haven't done it yet in Accurate ECN, but actually you could have a time before you reply with the CE, because if you're doing stretch acts, there's not necessarily any need to respond to each CE, because you may be getting a lot of them, and you only need to wait a certain amount of time and then report how many you've received. You don't actually need to do it. Yeah.
Discuss this on the mailing list. It'll be a good topic to talk about. Yeah, we know. Let's just go for this. Okay, go for it, Colin.
Okay. All right. So we have, Gori and I have a draft on looking at the impact of transport header confidentiality and encryption on network operations and the evolution of the internet, because we're thinking big. Next slide, please. So the point of this draft, right? We're beginning to see transport protocols, of which QUIC is the prime example, which do end-to-end encryption and integrity protection of the transport layer headers. So things like the sequence numbers and their equivalents. This obviously has some implications. It has some implications for the way we build transport protocols. It has some implications for the way people build network monitoring equipment, which tends to look at the sequence numbers to see if there's packet loss and to infer round trip times and things like that. So the draft is trying to do a review of the in-network uses of this transport, the transport layer header information. It's trying to review some of the implications of the fact that we're now encrypting this information or integrity protecting this information, and discuss some of the impacts that these changes are having on the network and the way people manage networks, and also in a slightly more philosophical way, perhaps consider the impact on the way we design transport protocols and the way the IETF does standardization, as it becomes difficult to monitor what's happening and to get wider input into the dynamics of the transport protocol operation. Next slide. So the draft has been around for a while. We've had 3 revisions since the last meeting. We got a bunch of comments on the list from Al, from Chris, from Kathleen, from Spencer, and from Joe Touch, which we believe we've incorporated. We've done a bunch of readability fixes. We've tried to give a more neutral point of view and to expand the security considerations. Next slide. So the 2 big sets of changes, firstly to try and give a more neutral and more balanced discussion of what's going on. Not to advocate any particular viewpoint on whether this encryption of the transport layer headers or the various uses of the transport layer headers in the network are good things or bad things, but just to try and document what is actually being done. In addition, we've expanded all the various introductory remarks about the ossification and the reasons for encrypting the transport layer headers as a way of preventing ossification, and added some notes about the implications for accountability, network neutrality, and the like. And again, we're trying to do this in a neutral way to avoid advocating for any particular side and just factually document what's going on. Next slide. In addition, we've actually written a sensible security considerations section for the draft.
This mostly talks about the implications on avoiding ossification versus exposing information to the network, the ability of preventing various sort of data injection attacks and the like. Primarily, given the nature of the draft, this is sort of summarizing and summarizing on the issues which we then elaborate on in much more detail elsewhere in the draft. Next slide. So this has been running for about 18 months. We've got a lot of feedback. There seems to be a lot of interest from people in this working group. We think it's useful to try and take a step back a little from the actual ongoing standardization of QUIC and reflect a little about the broader lessons from the development and deployment of these protocols, and try and learn some of the more general lessons about it and think about how they apply to future protocols, network operations, the way we do things in the IETF. And that's the sort of thing we're trying to get across in this draft. Accordingly, we'd like to ask this working group to consider adopting it as a working group draft. We think it's in pretty good shape, and we think the topic is important. So if there are any comments, I'd be very happy to receive them. And as I say, I'd like to request the group consider adopting this as a work item.
Okay.
Jana, I came here first because Brian's legacy is broken, so I get to go. And Brian's standing behind me with a stick in his hand.
I can see him raising that stick behind you.
I did not think of that. So thank you for presenting this. I haven't read the draft in detail, but I've seen it in previous iterations, and I'm definitely intending to read it. I wanted to say that it's very good to see the ossification text show up in the introduction, because that was in big part one of the motivators for actually encrypting most of the header was, in fact, the ossification that we have seen. It might be very useful to actually list out some of those things that we are suffering right now. Specific examples of them are TCP fast open. We have some data and some presentations that have happened in the past from Apple folks and from others on problems with deploying TCP fast open because of strange middle box assumptions about TCP. Similarly, MPTCP, there are examples of that as well. I think Christoph has done that in the past. I think examples of that kind might be useful, because those are in fact direct motivators for why QUIC at least chose to encrypt a lot of its headers.
Yes, I think that's a good idea. If you can send some pointers.
Jana?
Happy to do that. Thank you.
Quick question, pun intended. Do you think this draft is something that would be good for this working group to work on?
What's it? Is this like an informational document?
Yeah, I guess it would probably be informational. Yeah.
I think as a way of documenting something that QUIC has done, this might be a useful thing to do. Like we have gone through the considerations that are in this document. It'd be useful to make sure that the people who are proponents, not proponents, but the editors of the QUIC working group, people who have been talking about introducing network signaling into QUIC, all of them have a look at this and make sure that their points of view have been represented. If all of that can be done, yeah, I think it might be a useful thing to have.
Thank you.
Hi, Brian Trammell. I have not read this version of the draft yet. It's on my list of things to do. I was of the opinion last time that this should be adopted in this working group. I continue to be of that opinion.
Thank you.
One question, so like there was a very, very, very long process that went over sort of the encrypt draft, which this one refers to, which was sort of the more general arrangement. I think we learned some things from that process, and I think that learning is reflected here. How do you see this draft how do you see the positioning of this draft with respect to the wire image and pass signals drafts that we talked about in TSV area? Do you see it as complement, or like, I mean, they talk obviously about the same things, but is there something we should be doing together on these, or it's just like, hey, these are different groups that have different viewpoints and different opinions? I mean, it turns out to be pretty much the same opinion, but
it's certainly similar issues. Yeah, yeah. It looks like Gary certainly has an opinion on this, seeing him running up.
Gary first, I could try an opinion. I mean, I suspect the IAB are going to provide us with some guidance on the way forward. And I suspect if this document is okay, you hope to, okay, that's good. And if this document is well written, it's going to indicate there are giants over here, there are giants over there, there are good things over here, good things, but no real guidance probably, because we don't yet have guidance. We have experience from the past about building things, and we understand how they're used.
Yes,
So they're making
this document is raising issues and documenting issues rather than giving guidance. Certainly.
So we didn't actually talk about, at the TSV area thing, we didn't really talk about the split between those two documents. The first document, the wire image document, really just says, here's what we mean when we say wire image. It actually refers to this document as an example of the type of places we're considering, these considerations are coming to the forefront.
Yes. And there's possibly terminology this document can be used.
Right, yeah, so we should, right. I think wire image is pretty close to done, personally. I hope that comes out for community review September, October. And then, yeah, so please have a look at it. And if there's feedback from your process here that makes sense in the scope of that document, with the understanding that that document should have limited scope. The pass signals draft is much older. Actually, it's been kicking around for a while. It's probably a little bit more controversial even within the IAB. And that essentially says you must think about these things, right? You must think about the impact of non-visibility, and maybe the outcome of the thinking about it is, yeah, okay, that was on purpose.
Yes.
So to some extent, this is a transport-wide consideration that we're asking for. So that's probably the extent of the guidance that's going to come out of the IAB.
Yeah. And that may be all we can give right now.
Exactly.
Until we have more experience.
Okay. This is cool. Please, yeah, I'd like to see this. This is the right working group for it, clearly. I like the scope. I like where it's going. I will read it and provide feedback.
Okay, thank you.
Craig Taylor relaying from Jabba. Abdussalam would like to know how much review have you had and comment back on the mailing list?
I mean, we in one of the previous slides, we listed half a dozen people who have provided input since the last meeting. We believe we've engaged with them and addressed those comments. And I forget exactly who, but there have been previous comments on previous meetings. Yeah.
I'll note to expand on Colin's remarks that both of the authors of the MM-Encrypt doc that was referred to earlier are among the reviewers listed here and have commented. And I'd like to thank both Al and Kathleen for doing that.
Yes. Yes. And we had a very long discussion with name blanking security person earlier in the year as well.
We have. And in addition, it's being presented in V6 hops and will be talked about there again when we know what we're doing here. So, and these people provided quite a bit of feedback from the V6 Ops community, which has been very, very helpful.
Mia Kulevin. So there's a step between just listing the use cases and giving some recommendation or developing solutions or whatever that means. And the step in between is to kind of analyze the use cases, figure out what the benefits, what the risks are, and getting some agreement in the community, what we want to support, what's good, what's bad a little bit. That's a hard step. The more you can get in that direction, the harder it will be to proceed with the document, but the more useful it can get.
Yes. I would suggest the IAB has a draft that seems a good place to put that complicated discussion. I don't know. Yeah. I mean, that's one of the things we need to figure out is the balance between how much of that goes in the IAB draft and how much goes in here.
So I'm looking at Al, who is sort of, thank you. Is there anything more that we ought to be aware of here about the adventure with the MM-Encrypt draft? And can you say anything interesting about the relationship of this draft to MM-Encrypt?
Al Morton. I'm really glad to see the whole slide on neutral point of view. I learned a lot about that. And I found that there's a really good tutorial on it in Wikipedia.
Yes.
And so I encourage other people to find that and take a look at it. I support this draft going forward. I also support the reestablishment of the support group for IESG and other review stress disorder. So, and you're welcome to join. I wish you luck with this, and I'll do what I can to help. Thanks.
Thank you. On that note, hi, Spencer.
Indeed.
And the other draft is about to be RFC 8404. I finally finished Auth 480.
Spencer, I think you're live. Can't hear you say anything.
I was just waiting for Al to finish. So I wanted to also mention that one of the sets of comments you got was from me as one of the editors of the Marnu IAB workshop report, and because that was me, and I see that also as a lot closer to being, kind of encrypt kind of document than this. I was really pleased to see this document being just descriptive, just from the transport protocol perspective, and not trying to do more than that. And I really think that that's going to shorten the stay of these authors in the ISG support group meetings, which will probably continue for some time. But thanks.
Sure. Thank you.
Mia Kulevin again. I want to give some piece of background information on the mEncrypt draft, and correct me if I'm wrong, but that was an AD-sponsored individual draft, so there was no working group behind it, and it will be finally published without IETF consensus, just to make the confusion about the IRTF series more complete.
Okay. All right.
All right.
Okay. Okay. So it's time to figure out what to do with this. Please raise your hand if you've read the draft. I see a good. Or sorry, read any version of this draft. I see well over a dozen hands. That's really good for this group. Okay, it's hum time. Hum, if you think the working group should adopt this draft and work on it. And hum, if you think we should not work on it. I heard a clear hum in favor of adoption, and I heard silence the second time. So I believe we're going to adopt this. We will verify that in the list to see if there's any objection. Thank you very much, and thank you for working on this.
Okay, thank you.
I think his proxy is going to do it. We can run a little bit over if we need to. Let's go have some fun here.
Awesome. All right. I'm Eric Kinnear from Apple, and I'm not Tommy, obviously, but at IETF 101, a strategy for encapsulating IKE and ESP was presented in TSV area. And there was some interest expressed in having a document that kind of codifies the problems with doing that and the concerns around doing that independently of IKE or ESP, but just as a general, what happens when you try to do this kind of thing. It's meant to be an informational reference for other things that support tunneling any sort of protocol over TCP, and it kind of covers some of our experience with experimenting with that. But one of the primary things we'd like to hear from all of you is like, what are the other cases that you have to do this, and what are the other pitfalls that we haven't captured here? I'm sure there are more. It would be great if we could collectively enumerate those so that we could write them down and other people could look at them. So to get it out of the way, this document is not intended to say go encapsulate TCP within TCP and it's a great thing. It says here's all sorts of ways it causes problems. It's deliberately not trying to modify TCP to add unreliability or anything like that. So some of the strategies for doing this involve making one of the two TCPs no longer really TCP and just kind of fake. and that's out of scope here. And we're also not trying to say this is exactly the format that you must use on the wire to encapsulate things. We'd like to document multiple ways of doing that. If anybody has any other ones, we've proposed one, but there are lots and lots of ways to do that. So first, just kind of why do we even want this, especially around the VPN protocols case. There's networks that block UDP traffic and NATs that then time out with UDP at very, very different timeouts than they have for TCP. So really the reason you'd want to encapsulate stuff in TCP is because you want it to get there at all, not because you want it to get there in the most optimal way or the best way, which is why some of the concerns around performance and other issues are things that you kind of put up with because you do this when the alternative is you aren't going there today. So very briefly, we've proposed a link value format for how to do this encapsulation. If you have other formats, we'd love to chat about them and add them in. But it's very basic. You take what would have been your datagram payload and you prefix it with a length and you stick it on the stream. That allows you to find the delineation between them. And at the other end, you unpack them and send them along. You can also have some sort of type or demux value if you want to handle different types of datagrams and stuff like that. And the nice part is because this is a way to pack any sort of datagram onto a in-order byte stream, you can do this over TLS or TCP or anything else you want. This is just how to take datagrams and shove them over streams and what goes horribly, horribly wrong if you do that. Protocols that actually want to deploy this need to allocate a port. We're suggesting the parallel port from UDP. So the same way you have the IKE ports for UDP, if they're available, it's great to use those from TCP so things kind of line up in people's minds. So the meat of the content that we're trying to talk about here is kind of what can go wrong with this and what are the mitigations around how do you deal with it? And there are going to be concerns that don't have mitigations or don't have ways to fully mitigate it. So in a lot of cases, we've managed to partially make the problem less bad, which is not the same thing as not a problem. There's two cases that we're going to talk about. We're going to focus a lot on the second one. So the first one is if you were previously sending UDP inside your datagrams, and now you're encapsulating it in TCP, you've added unneeded reliability because usually somebody on top of that is handling it. And so that's not great, but it's not nearly as concerning for many people as TCP within TCP, where now you've got all sorts of other issues because you're doing two congestion controls and et cetera. So diving right into those, yes.
Mia Kuliman, I wonder if we want to make an even stronger architecture recommendation here and say, even if you have reliability on top, you should not like redesign your protocol and try to remove it to save a couple of bits, because that's even more confusing to users. I'm not sure if I think that would be the guidance I would give. I'm not sure if there's agreement.
Yeah, from my perspective, I think that would make a lot of sense. It effectively, if you have something on top like that, you're effectively in the second bucket here. And don't try to screw with it to move around where you are. So just a little bit of terminology of how I'm going to talk about this, because you start, when you have duplicate copies of anything, the which one you're referring to starts to become very repetitive. So I'm going to talk about an outer tunnel, an outer TCP, and inner flows that are going through that outer tunnel. So you have an inner TCP and you have an outer TCP. One of them is tunneling the other traffic through. And we're going to cover just 3 concerns, which is all that's in the draft right now. So if you have more concerns than these, we'd love to add them and make a 4 and a 5 and a 6. But the first one, and I think the main core of a lot of the other issues that happen, are that because you're running 2 different loss recovery contexts, the inner flows experience loss on the segments that are tunneled inside of the outer ones as delay, not as loss. And so that confuses things. The second one is going to be some stuff around how the congestion windows tend to interact and how buffering and buffer bloat start to really become a pain. And the third one is going to be head of line blocking, in the sense that you are now using a in order reliable byte stream for what might not have cared about being in order or reliable. So the big one is like I said, the inner flows are going to see any loss on the network segments that are tunneled inside the tunnel as delay, while the outer tunnel makes up for those losses by retransmitting. And that can confuse things because effectively, instead of going through fast retransmit and knocking your window down and everybody backs off a little bit, you think, oh, everything is great. There's just some buffer in the middle. And if you're using purely loss sensitive congestion control, now you build all the way up until that delay is so bad that you experience a full timeout and have to start all over and go through slow start again, and that's really unfortunate. So this one's kind of nice because there is a potential mitigation here, is if you use congestion control like PBR or something like that that uses delay as input, you're happy because now the signal from the network about, okay, you're going too fast, you need to back off, the outer tunnel backs off, and all of the inner flows also do because that signal is propagated through. It's just propagated as delay instead of lost directly. There's one kind of side effect that we were kind of surprised by when running tests about this, is if you have a very minor little bit of loss that and you have a short enough RTT that you can make up for it very quickly, the outer tunnel is actually going to hide some of that loss from the inner flows, and they will on occasion complete faster, although I don't expect that to hold true for the internet at large. So with very small amounts of loss, it can be kind of nice because there's minimal delay because fast retransmit tends to work very well in catching up, and then your inner flows don't actually back off.
Brandon Williams, Akamai. There are some similar issues with tunneling or sending TCP and interactions between TCP and network coding, and there's some discussion ramping up that kind of goes in fits and starts in the network coding research group. There, some of the work that we've done sort of amplifies what you're saying here about using delay-based congestion control. That's an approach that we've found effective in the network coding context.
Nice.
I believe some of the discussion that's going on in the research group looks at another approach. They might be experimenting with actually using ECN on the inner flow as a signal to
say, hey, I had a problem,
say, hey,
back off.
I encountered congestion, back off a little bit.
Yep. That's awesome. Yeah, it sounds like we should talk a little more. But yes, so ECN would be great. There are other signals to bring that in. And we'd love to add that in here as well. So if you have, and also if there are other use cases of times where you'd want to be tunneling things like that one, we should cover those too and make sure we get everything.
How many more slides do you have?
Effectively 2 more.
I'll wait.
Cool.
Thank you, Jana.
So the last point on this slide that kind of makes a lot of the other schemes that you might try to come up with to be really, really sneaky fall to pieces is that very often after you get outside of the tunnel, those inner flows need to then be out on the wild internet, or at least they have multiple hops that they need to go through before they get to their final destination. And so they still need to be fully functional in all the ways that implies. So you can't otherwise tune them with crazy parameters that would mean they just don't retransmit because they don't need to while they're in the tunnel, because then when packet loss is experienced after the tunnel, now they don't retransmit there and you're screwed. Yeah. So next piece, which is very related, is now that you've got all of these guys who are seeing delay or potentially seeing packet loss beyond the tunnel, anytime somebody retransmits for a loss when they time out within the tunnel, that is effectively a spurious retransmission, because the outer tunnel is going to make up for that loss eventually, even if it's taking it a really long time. So it may be that 300, 400, 500 milliseconds later, it comes back and you get your original ACK for the original segment, and you've already timed out and retransmitted that entire flight. And so now you've dumped a whole bunch of other data into this tunnel, and the tunnel doesn't know that this is duplicate data, that this is a waste of time. And so it very happily delivers it. And outside the other end of the tunnel comes this huge dump of duplicate packets. The network on the other side is like, what the heck, man? You just handed me a whole wheelbarrow and then you brought in another wheelbarrow too. So that causes some problems. That's one of the ones that we don't have a way to fully mitigate. Effectively, you can do some sneaky things if you make the retransmission timeout of the inner flows slightly higher by at least 1 RTT of that of the outer flows, or that of the outer tunnel. You can kind of try to avoid that because the outer one will give up and retransmit before you kind of hit this problem, but you still have a point at which you fall off a cliff. And the one thing that does give us a little bit of hope here is we've seen that you don't fall off of this cliff until you have fairly significant packet loss in the high-ish single-digit percentage, which is not too far off from where TCP falls off a cliff all by itself. So you definitely fall off the cliff sooner, but it's not like you suddenly just, the floor drops out from under you immediately. The other concern here is you end up with multiple layers of slow start. So after you fall off of this cliff, waking everybody back up and saying, all right, let's get back to a acceptable sending rate means you effectively have to push the window open of the outer tunnel while you're also trying to push the window open for your inner flows. And so you now are effectively doing twice as much work to get the packets across once you've fallen off a cliff, so your recovery is slower. That's it for this slide, and I did not advance. The last one here is head of line blocking. So now you've got this in order byte stream that you're putting things that didn't really care about being in order on. And so when you fall off of this cliff and you have a problem, any kind of timeout like that on the outer tunnel means that every other flow is blocked while it makes up that lost packet. And so everybody who is trying to sneak their way through here is suddenly blocked by the fact that one of the packets got lost. And that is part of what contributes to that burstiness coming out the other end of the tunnel is all these people who are blocked and waiting up and just sitting there on the other side waiting to be delivered for that last segment to be filled in. It gets filled in and everything dumps and goes out. That's also very true of a lot of things that end up being tunneled, but is still painful when you fall off that cliff. And it also means that if there is loss outside of the tunnel on one of the inner flows that it then needs to retransmit for, and the tunnel happens to be blocked, it now can't make up that other loss that it actually does need to retransmit for. So somebody else's spurious retransmissions screw up your legitimate retransmissions that you desperately need in order to make progress. So this is the kind of partial mitigation here that I mentioned a little bit earlier, is effectively if you can tune some of your timeouts, you can make it such that you fall off the cliff a little bit less often, but you still, in significantly high loss scenarios, you still are going to end up falling off a cliff. Fortunately, it's not too far away from where TCP does all by its lonesome. And that's it.
So, Gary Fairhurst, a quick clarification question. The second wheelbarrow of packets, which were exactly the same, you said it caused some problems? Is it just because you're sending too much data, or?
Well, it can cause some problems on the other side, on that last mile of the network, where you're now an independent flow that needs to operate all on its own. Because even if that network was desperately signaling to you by probably tossing out your packets that it couldn't handle everything, you haven't seen that yet.
Yeah.
And now you just hit it with a whole nother blast of packets, and it goes, whoa, there, what are you doing?
That's why this draft is so much fun. Thank you.
Need to keep this fairly quick so we don't use the whole breakup here.
Yeah.
Jana Iyengar, I feel like you really should be using the word channel in the TCP or something like that somewhere in here.
There's a lot of words we could.
I know. You might be able to make some interesting. If you control the channel endpoints, which seems like that's sort of the situation you're thinking about. The tunnel endpoints. I'm sorry. That you might, if you're able to make guarantees on how you packetize on the send side, you might be able to pull the inner TCP packets out of order and ship them along, reducing the burstiness and so on.
Yes.
So you might be able to do some tricks there. I mean, you don't have to specify them, but you might want to allude to that in the.
That would be good to mention. We did some experiments with that, and at least under not particularly real world conditions, it didn't give us that much of a win. But I would imagine as you start varying all the parameters for how a network could behave,
Right.
that it would help significantly.
Yeah, it might be useful to mention that. The other thing I want to point out is that you don't want to make assumptions about the congestion controllers.
Yes.
On the outside specifically. If you're assuming that it's loss based or the inner one is delay based or not, then you might have issues. At least just keep that in mind as you.
That's a good point. We should do a read of the text from that mindset and clean it up a bit, because right now it's pretty dirty.
Yeah. Mira's going to be the last on this.
Hi. Colin Puggins. So we did a very similar encapsulation for RTP stuff in RFC 4571. I believe there are also similar things as part of RTSP and Turn TCP. You probably want to reference some of those.
That would be great.
I would actually suggest you might want to list this as updating RFC 4571, since it's the same on the wire format. And I think the people who implement that, and I believe it is reasonably widely implemented, would do well to read what you have written. And if you list it as an update, they might see that.
That's a really good thought.
Mm.
I like that. Yeah.
Mia Kulevin. So especially regarding the migration techniques you described, it might make sense to distinguish between an encapsulation where both of the endpoints are the one encapsulating and decapsulating, or where you actually have a tunnel just somewhere in the middle.
Yes, that would be really good.
Okay, I've got one question that I need to ask, which is, how many people have read this document? 1, 2, 3, 4, 5, 6, perhaps. That's good.
I was going to simply comment. This is well, definitely want to encourage the work here. It's highly germane to this working group, but for no other reason than both Gori and I have analogous scars in dealing with UDP encapsulation and guidance for people who want to do things like encapsulation with UDP.
Okay, so thank you. Please continue the work. Please discuss this on this list. This seems within the scope of this working group. Also, we have a 15-minute break for people to do whatever they like. And please come back.
Yeah. We will start promptly at 10 after.
All right. Okay, that wasn't bad. This one could be very interesting. John's comment that don't assume congestion before make it operating.
Yeah, you might be computer from the inside and something else from the whatever, yeah. But that's why we might need to do some work in this space.